Right then, so today is our last video, I think, on adding fractions. So you're basically doing the exact same as yesterday, but what I thought I would do today is instead of adding two fractions, I have decided to show you how to add three fractions. And I know this question has appeared quite a few times the last couple of weeks. But it is there as a bit of a challenge question. So I thought I would show you today and see how we get on working this out. So I've made a question up. Try to keep it as similar to the style of question you guys have had. So my question today is going to be 2 1/3 plus 1 1/4 plus 1 4/6. So I've got three fractions here to deal with. But it's fine. Do not fear. It's not as scary as it might look. So, as always, I'm always going to say this. You do what suits you. You do what method works for you. There's several methods you can use. Ultimately, as long as the answer's right, that's the most important thing. So I'm going to teach you this method, which will break down the steps into manageable chunks for you to use. All right, so job number one. They're not too bad, these numbers, but I'm going to convert all of these into improper fractions. So my first one, 3 times 2 is 6. 6 plus 1 gives me 7. I've then got 4 times 1, which is 4. Add that 1 gives me 5. And then finally over here, I've got 6 times 1, which is 6, plus the 4, and that will give me 10. So I've now converted all of these from mixed numbers at the top into improper fractions underneath. So the next job now is converting these three fractions and make them all over the same denominator. So you might be able to look at these three numbers and think quite quickly what our common denominator is going to be. And there's a few ways you can do this. The first way would just be by knowing your times tables really well, inside out, back to front. What you can do, and what you might find as you start getting more challenging questions, is you could do the multiples method, which will work. So I'm just going to write these out just to prove to you that the multiples method, it does work. So I'm just going to write out a few multiples of each times table. So let's go 3, 6, 9, 12, 15. I think I'll go up to 15 on this one. 4, 8, 12. Now I want to stop there. I'm not going to write any more out because I've just spotted that 12 is actually in this one as well. But I knew that because I've done lots of questions with 3s and 4s in before. And actually now I only have to do that because I've just noticed that 12 actually is a multiple in the 3, the 4 and the 6 times table. Okay, that wasn't too bad. So we've now got 12 as our three denominators to work with. So just as we have done before, we're going to ask ourselves, how do we get from 3 to 12? 3 times 4 is 12. Whatever we do to the bottom, we do to the top. 7 times 4, that is 28. 4 times what is 12? It's 3. And 5 times 3 is 15. And then 6 times 2 will give me 12. Therefore, 10 times 2 gives me 20. So I've now got my 3 fractions all over the value of 12. So we have to add these all together now. So I'm going to rub this out to give myself some working out space. You've obviously got lots of paper, back of your book, whatever works for you at home. I've just got a small board to work on today. So I've got these 3 numbers, so I'm going to keep my denominator the same, keeping that as number 12. Now I've got these 3 numbers here. I've got 28, 15 and 20. So you might be able to add it in your head, which is great. I'm going to write it out as a column addition sum over here. And that's just because I would like to do that. And you can do this as well. So we're going to add this up. So I know that 8 plus 5, well that's 13. I'll carry the 1 down here. So now we're going to add the tens column. 2 plus 1 plus 5. Sorry, 2 plus 1 plus 2 gives me 5. Plus the 1, that gives me 6. So I've now got 63. So 63 over 12. But what's the rule? We should all be doing this by now. I hope. This needs to change into a mixed number like in my question over here. So again, 12 times tables. I'm going to write my multiples out. I like doing this. It helps me out. And when you start getting bigger denominators, as I've said before, you will find it helpful. So then my multiples are 12 up to what I'm going to need. So that division sum again. Thinking about it, I've got my multiples here. Wow, 12 times 5, well that's 60. 12 times 5 is 60. Denominator stays the same, keeping that 12. How many are left over? I can see 63, take away 60. Oh, it's going to be 3. So my answer is 5 and 3/12. But I think I've noticed something about this fraction. There is something that I can do to 3/12. So I can simplify this further. I'm just going to fill it in just down here before I run out of room. So I know that 3/12, both 3 and 12, so 12 is a multiple of 3. So I can put, 3 divided by 3, that's 1. And 12 divided by 3 is 4. So my final answer, my final absolute simplest possible answer that I can get is going to be 5 and 1/4. And that is the perfect answer, that is. That is the dream answer, that is. It's in its absolute simplest form. This is correct. Technically, this is correct. Technically, this is correct. This is the perfect answer. So this is just how you would add 3 of these fractions together. The exact same method, you've just got more to deal with over here.